Hi, good morning, everyone, and thanks for joining the session today. So let's make a quick start. We are looking at discussing learning outcome 4. And today's learning outcome 4 is going to be specifically discussing just the immune system. So what we are looking at is obviously the human body's immune system, and specifically looking at what it consists of. So when we talk about the immune system in the human body, we are going to be looking at understanding what it consists of, how does it help in obviously defense against infections and diseases, and then we'll go into some of the assessment criteria which are going to look at differentiating between active and passive community immunity essentially. Then it will be looking at also understanding the major forms or components of the immune system, and at some stage what we'll also be looking at doing is going into a bit more detail into terms of understanding how does the immune system play a role in our immunity, and then looking at certain differences between primary and secondary immune system and the responses that the immune system actually produces. So let's start with this particular discussion. And what we will do is go across into key terminology first and look at some of the key components of the human immune system before we go into details. So yesterday's session, gave you a good idea, I hope, in terms of, the different types of cells. What are these different types of cells in the body which essentially help in fighting the infection or the external pathogen which is trying to enter the body? We looked at innate immunity, we looked at adaptive immunity, and also, immunity which can be acquired through the route of vaccination. And we then went into details of, different types of white blood cells, which are leukocytes. We looked at the T helper cells. We looked at the, B cells, the T cells, and also the macrophages, which are essentially the second type of, white blood cells. We also briefly discussed the non-specific defense mechanisms, which the body has, and they tend to be, the external or physical barriers that are present on the human body, which prevent pathogens from, hooking onto the body or getting into the human body through the bloodstream. So we looked at things like the mucous lining, the cilia, the skin, and the nasal hair that we have, or essentially ear here that we have, which prevent, the entry of pathogens into the human body. Now, today's discussion is primarily on understanding, what is the immune system. And there is a very good video which basically summarizes, and talks about the human immune system. This video is something which is a 15-minute video. I'm not going to play the entire video, but what I've done is obviously place the link of this particular video on the PowerPoint slide. And what my suggestion would be that if you watch this particular video, for those of you who haven't had, say, for example, or don't have a good understanding of the human, physiology and the makeup, I would suggest that this video would be, obviously one of the key videos that will kind of apprise you of what the immune system is, how it does, and how it kicks into in terms of, when the human body is looking at defense against pathogens. So let's listen in and see this video for a couple of seconds, because obviously, as I mentioned, it's a long video, 15 minutes. This is something which I would suggest that you watch offline. And then when you look at, some of these videos, if you do a search on YouTube, you would also see on the right-hand side, you'll get a number of other videos which normally come up, and they are also related to the immune system. So watching one or two of them essentially would hopefully give you some more details into what we are going to study, in terms of the specific immune defense mechanism which the human body employs when we look at the entry of or when pathogens like virus, bacteria, fungi, protozoa, different types of microorganisms or macroorganisms try to enter the human body to cause infections. Let's listen in.
This is Tom from ZeroToFinals.com. This video was designed to give an overview of immunology so that you understand all the basic features of the immune system. It will also help you to return to this video once you've already learned the detail so that you can again fit those details back into the bigger picture about how the immune system works. The immune system can be categorized into the innate immune system and the specific immune system. The innate immune system consists of the components that are already at the location of the infection and respond immediately with a generalized response. The specific immune system involves specialized T and B cells that are waiting in places away from the site of infection, and then when they're activated, they launch a specialized system that fights the specific invading pathogen. The specific immune system takes a little while longer to recognize the infection, particularly when a pathogen is invading the body for the first time. So in this video, we're going to cover both of these systems and also talk about a system called the complement system that works alongside the innate and specific immune systems. Let's look at what happens when a pathogen invades the body. Initially, there are physical barriers that need to be broken before an infection can take place. The skin is an example of one of these barriers. Most invaders will get stuck at this barrier. However, occasionally an invading pathogen will get through, such as when there's a cut in the skin. As well as the skin, there's other physical barriers, such as the mucosa of the respiratory system, the gastrointestinal tract, and the urinary tract. There are also chemical barriers that help destroy harmful pathogens before they can cause any infection, such as the hydrochloric acid in the stomach, lysozyme in sweat and tears, and lactic acid in the vagina. Let's look at the initial responses of the immune system once an invading pathogen has broken through the physical and chemical barriers to infection. Three things happen. Number one, macrophages recognize the pathogen and activate the innate immune system. Number two, dendritic cells pick up antigens from the pathogen and then head off in the blood and lymphatic systems to track down the relevant T and B cells of the specific immune system and activate them. And number three, the invading pathogen activates the complement system directly via the lectin pathway and the alternative pathway, and we'll talk a bit more on those later. First, let's look at how the innate immune system provides an immediate response to infection. The first to respond are the macrophages. They recognize pathogens by specific characteristics that occur on pathogens but don't occur on cells of the body. These characteristics are called pathogen-associated molecular patterns, or PAMPs. They recognize PAMPs using various receptor types, including toll-like receptors. At this point, I need to talk briefly about a process called phagocytosis. Now, phagocytosis is the process that macrophages and other phagocytes like neutrophils use in order to destroy pathogens. So what happens is, once they've recognized the pathogen, they start to wrap their cell membrane around that pathogen and absorb them to within inside their cell. The pathogen is then left inside something called a phagosome, and this phagosome fuses with surrounding lysosomes that provide digestive enzymes that then break down that pathogen, destroying it, and also processing all of the components into harmless waste products. If the invading pathogens are harmless enough that the macrophages can deal with them alone, then they're cleared and it goes no further. If the attacking army is too great, the macrophages need help, so they release cytokines, which are signaling proteins, sort of like local hormones, that sound the alarm of an infection in the local area. This leads to a process called inflammation. One of the most important actions of these cytokines is to recruit and activate more cells of the immune system, such as macrophages, monocytes, and neutrophils. Monocytes are precursors to macrophages that float around in the blood. Once they enter tissues, they differentiate into macrophages and can then carry out all the processes that macrophages normally carry out. Neutrophils are another type of phagocyte that circulate in the blood and can enter the tissues and help by destroying invading pathogens. The response also involves a number of other processes that help to contain and fight the infection. These are vasodilation, increased vascular permeability, mast cell activation and degranulation, releasing more cytokines that further stimulate the inflammatory response, activation of the clotting system, and activation of the kinin system.
Use Bob's robust KPI dashboards, insights, and reports to build smarter strategies.
As you can see, we discussed everything yesterday, which is being covered in this particular video. So let's listen in a bit further.
Itself actually stimulates macrophages and neutrophils to secrete more cytokines, notably chemicals called interleukins. This is known as the acute phase response, and it leads to a more systemic inflammatory response. This involves sending cytokines, specifically interleukin-1, to the brain to tell it to produce a fever that leads to high temperatures that are poorly tolerated by many pathogens and cause reduced appetite and lethargy so that the person conserves more energy that can be used to fight the infection. It also involves sending interleukin-6 to the liver to produce acute phase protein that act as something called opsonins. And remember this word because we'll talk about opsonins in a minute. Additionally, interleukin-8 is released that recruits and activates more neutrophils. Interleukin-2 and 12 activate natural killer cells, and tumor necrosis factor alpha is released that does all of these effects by itself. As I just mentioned, I want to take a quick look at opsonins, as these are very important in the immune system. Opsonins are complex molecules that attach themselves to pathogens and make it easier for macrophages and neutrophils to recognize and phagocytose that pathogen. I think of them a bit like a fork that spears the pathogen so that macrophage can attach to the other end of the fork and then use it to eat the pathogen. An example of an opsonin that you may have heard of is C-reactive protein, or CRP. CRP is produced by the liver in response to interleukin-6, and we actually measure the level of CRP in our patients to assess how much inflammation there is in the body. And it can be a really good indicator of the severity of the infection that our patient is suffering with. So that summarizes the innate immune system, a generalized system that recognizes and responds to an invading pathogen by causing an inflammatory response and recruiting cells that destroy the pathogens by phagocytosis. Next, let's look briefly at the complement system. The complement system works alongside the innate and the specific immune system to help them destroy pathogens. This involves a series of complement proteins labeled C1 to C9. Once the complement system is triggered, the proteins start to activate each other in something called the complement cascade. Various products of the complement cascade have important functions such as acting as opsonins, triggering further inflammation, and directly attacking and destroying the pathogens. The complement system is triggered in one of three ways. The lectin and the alternative pathway are activated directly by pathogens, and the classical pathway is activated by antibody-antigen complexes that arise from the specific immune system. And that brings us nicely onto looking at the function of the specific immune system. The specific immune system involves two characters, the T and the B cells, and these are both types of lymphocyte. They are free to float around the lymphatic system and the blood, but they spend most of their time in the lymph node and the mucosa-associated lymphoid tissue. Think of these lymphoid tissues as army barracks that are full of soldiers that are all sat around waiting to get word of an enemy that they've specifically been trained to fight. Each pathogen has molecules that are unique to them. They're known as antigens. Each T cell has T cell receptors that are specific to a single type of antigen. B cells have antibodies on their cell membrane that, just like T cell receptors, are specific to a single type of antigen. The result is there's millions of different T and B cells that are all specific to a single type of antigen.
So this is going into a bit more detail with regards to what was covered yesterday by talking in terms of pure biological terms as we normally do that in the field of immunology, which is related to the immune system. So let's listen in.
Causes an infection. The T and B cells that are specific to that pathogen need to be alerted. The trouble is they're sat in lymphatic tissue such as lymph nodes while the infection is happening somewhere completely different. This is where the dendritic cell comes in. These cells are like messengers and they pick up the antigens at the site of the invasion, display them on their cell surface, and then bring them through the blood and lymphatic system into the lymphatic tissue. When they're there, all the T and B cells have a look at the antigen and see whether they recognize it. When the T and B cells are found that are specific to that antigen, those cells become activated. So the specific immune response starts with the dendritic cell, presenting the antigens on their HLA class II molecules to the CD4 cells. These CD4 cells, which are a type of T cell, then proliferate and become T helper cells. The T helper cells present antigens on their HLA class I molecule that can be recognized by CD8 cells, another type of T cell. They also secrete cytokines that are responsible for making the CD8 cells proliferate and differentiate into cytotoxic T cells. These T helper cells also release cytokines that stimulate B cells to proliferate and differentiate into plasma cells that can release large quantities of antibodies, and memory B cells that hang around as part of the immune memory to respond quickly in future infections with that specific pathogen. The T helper cells also travel to areas of infection and secrete cytokines that help to recruit monocytes and macrophages to the infected tissue and activate the macrophages to cause inflammation and start the process of phagocytosis. Cytotoxic T cells are responsible for killing cells that have been infected by pathogens, such as virally infected cells. To do this, they need to attach themselves to the infected cell via the T cell receptor and the HLA class I molecule expressing the relevant antigen protein on the infected cell. Once they're attached to the virally infected cell, they have two killing mechanisms that they can choose from. The first is called granule exocytosis, where they basically spray the infected cell with enzymes that destroy the membrane and lead to cell lysis and cell death. The second is they can activate the FASP molecule. The FASP molecule is like a self-destruct switch that once it's activated, it causes the cell to undergo apoptosis. Plasma cells and antibodies are an essential part of the specific immune system. Plasma cells are B cells that have differentiated and become antibody-producing cells, and their job is to produce tons of antibodies that are specific to the invading pathogen. These antibodies are proteins that are shaped like a one end is variable in shape to match different antigens, whereas the other end is fixed in shape and can be recognized by many cells of the immune system. These proteins float around the blood and attach themselves to antigens that match their specific variable region. And these antibodies help the immune system fight pathogens in a number of different ways. Firstly, they can attach themselves to enemy toxins, which themselves are antigens, and neutralize their toxic effect. Secondly, antibodies can attach themselves to the receptors of viruses and bacteria and prevent them from carrying out their function. For example, it can stop viruses from being able to recognize cells that it may want to invade, and therefore prevent the viral invasion of that cell. Thirdly, antibodies can attach themselves to pathogens, then clump together to slow the spread of that pathogen down. This is called agglutination. Finally, it can be very difficult for the simplistic receptors of macrophages and neutrophils to recognize certain pathogens. Antibodies can act as opsonins that are highly specific to the invading pathogen, and by attaching themselves to that pathogen, acting as opsonins, they can help the macrophages and neutrophils to recognize and destroy that pathogen.
So as you can see, this particular video kind of, very beautifully summarizes what we've been discussing, in Learning Outcome 2 and Learning Outcome 3. For those of you who haven't, watched the session that I've done, this particular video would help you in recapping and obviously developing a bit of knowledge about the human immune system, the different types of cells. Obviously, certain wordings here were slightly differently used, but things that we've covered yesterday in terms of innate immunity, adaptive immunity, and the immunity that is basically which the body develops through vaccination was also covered, and obviously the wordings in which how they've represented this in the video is slightly different, but most of the different types of cells, how they work, and what is their role and functions within the immune system have been covered in the previous learning outcomes. Now, with this understanding, what we want to be able to do is basically go directly into the assessment criteria and understand some of the other aspects of what are the other key players which basically are a part of the human immune defense system, and how do they help in preventing the spread of infection within the human body. Now, one or two things that would be good for you to understand is to look at going into, say, for example, when I say key terminology, what I would want to do is ask you to look at refreshing in terms of what is immunity and types of immunity. So here, the type would be active and passive. We will discuss this today in the learning outcome. This is something that you would need to be aware of. Then when we talk about the active immunity in particular, we will go into details of, the immune response, which basically the body produces in relation to an exposure to a pathogen, and then what kind of system kicks in, which is where the immune system kicks in to basically control the spread of infection in the human body. When we talk about passive immunity, we are going to be looking at talking about the concept where your body has temporary immunity, which is acquired when your body is already having specific antibodies present. So this was something which was related to in the video, is when your body already has an exposure to a certain type of pathogen, then the body already has what is called with the memory T cells, already has information about specific type of antibodies which are stored in the lymph nodes and the gastrointestinal lining of the mucosa. So when a pathogen tries to enter the human body, and if this is something that you've been infected before, then the specific type of T cells would come into action along with other type of cells like the neutrophils, the macrophages, and they will go through this particular reaction wherein they'll produce cytokinins and go through the process of phagocytosis to be able to encircle and obviously neutralize the pathogen cell. So in this case, this would mean that your body has already been exposed and it has what is called passive immunity. Now, what we also want to do is, for the understanding, is also understand what are the components of the immune system. So this is something that you need to be aware of. So when we talk about components, we talk about white blood cells, we talk about antibodies, we talk about the complementary system which was mentioned in the video. We talk about the lymphatic system, which basically stores the white blood cells. So if we talk about the lymph nodes, where the white blood cells and different types of white blood cells are stored, you look at the spleen, you look at bone marrow, where the white blood cells are actually produced, and then we also look at thymus. So these are going to be the components of the human immune system, and you should be aware of this particular aspect that if you are asked to, say, for example, talk about what are the various components of the human immune system, then, this is a diagram which primarily, should be referred to or should come to your mind when you think of the various types, of organs, or various types of, say, for example, cells which are stored in our body, and they basically form the first part of, first line of defense. And that first line of defense within the human body is nothing but the immune system. So we look at the mucus lining, we look at, obviously the lymph nodes, thymus, spleen, obviously the lining mucus, gastrointestinal lining, which is normally in your intestine, the bone marrow where the white blood cells are produced, the non-specific defense system, which are external and outside like skin, and obviously look at the mucous membrane, which is in the urinary bladder and your anus, and obviously in the reproductive organs like the genitals. So you have these systems which basically show the first phase of infection, which is basically inflammation. And inflammation is produced sometimes when you see tonsillitis happening, you see inflammation when a bite or a cut happens on the skin, you see inflammation which is normally detected through taking blood tests. And there were mentions of different types of cells, the CT1 to CT6 cells, which is normally when the bloods are done, it is normally measured to understand what level of inflammation is there in your body organs. And then the second thing that we see, which the immune system produces, is fever, which is primarily reducing basically reducing the body activity, but also increasing the temperature of the body, so that the external pathogen which has entered the human body should not be able to survive, because most of these cells have an ideal temperature in which they thrive. So essentially the body's reaction to infection is, apart from inflammation, tends to be fever, wherein the body temperature rises, the body reduces its functions, and obviously this is done to primarily act on the external pathogen by looking at destroying it by providing extreme temperatures in the human body. Now, the last thing when you... Yeah, go on. Yeah, go on.
I can't see anything on the screen. It's not showing.
All right. Okay. Give me one second. Let me share the screen. Yeah, let me share the screen. So when we look at, the bits that we have to understand about the immune system, one of the other things that you would need to know is the various, types of cells. So these types of cells would include the, obviously in white blood cells, we would need to break it down further into B cells, the T cells. We will need to look at neutrophils. We'll need to look at cytokinins. We'll need to look at macrophages. And then we will also look at, plasma cells. And then to a certain extent, we will also be looking at, because the reason why we need to understand the types of cells is because depending on these types of cells, there will be two different types of immunity, which, the human body immune system actually shows. And this is what we discussed yesterday, was humoral immunity or immunal response system. And the other one was cell-mediated, immune system. So, or immunity. So essentially, if you don't have a good understanding of the types of cells which are involved in the defense of infection, or in defense of fighting the infection in the human body, then it will become difficult for you to understand how the immune system actually works. Now, apart from when you have a good understanding of this bit of key terminology, which we have covered in Learning Outcome 1, 2, and 3, types of immunity, components of the immune system, different types of cell, but specifically focusing on leukocytes. Leukocytes being the white blood cells, And then there are different types of white blood cells which produce antibodies in response to the antigen which the pathogen is actually carrying. So this bit is required for you to understand, the specific defense which the human immune system produces when we are faced with, infections. Sorry, and that is what we are going to be looking at discussing today. In summary, when we go into each of the different assessment criteria, because what we are looking at discussing today is primarily understanding this specific immune defense mechanism. So understand the specific immune defense system or mechanism. That is the learning outcome that we want to look at. And in order to understand this, you would need to know in summary what is the immune system, what are the key components of the immune system. We will be looking at types of cells which play the most vital part in the defense of your immune system, and obviously look at controlling spreading the infection and infectious diseases when a pathogen infects or is detected within the bloodstream. So with this background in mind, let's go into and understand some of the details of what are the specific immune defense mechanisms that the human body employs when we look at pathogens entering the human body. So the first thing that we'll go into is trying to understand what is how do you differentiate between passive and active forms of acquired immunity. Now, we discussed immunity and we discussed different types of immunity yesterday. So when we look at the different types of immunities that we discussed yesterday, we talked about three different types in particular. So if you recall the three different types that we discussed yesterday, we talked about the innate immune system, which is the immune system which is the non-specific physical barriers that the human body presents to fight the pathogen, and they are immunity which are generally with you from birth. Then the second one was the adaptive immune system, and this adaptive immune system that we discussed, basically then breaks it down further into, through vaccination. When we acquire the immunity, there is adaptive immunity, and then the use of, memory cells when your body has been exposed to a pathogen or has had an infection previously, then these memory cells essentially, retain the properties of recognizing the antigen which is produced by the pathogen in the body, and then they basically replicate and call the, let's say the different type of cells which will be looking at essentially, fighting the response or providing a response in terms of action to the, infection. Now, when we look at going into details of acquired immunity, we would differentiate that into two different types. And these two different types would tend to be active and passive immunity. So when we talk about active immunity tends to be the type of immunity which occurs when as an individual, your immune system is exposed to the pathogen, which is either entering through, a physical barrier or through, say, for example, through the route of vaccination. Now, in this case, the immune system responds by producing antibodies which are specifically tailored to combat the, pathogen. And this active acquired immunity is long-lasting and provides protection against any sort of future infections that you may have from the similar pathogen. And this is introduced into the body through the route of vaccination, wherein you would normally have a harmless version of the pathogen being injected into the body, which will allow your memory cells and your lymphocytes to be able to produce antibodies, and they would then be stored in the body to be able to spring into action when your body is faced with that infection again in the future. The passive immunity or acquired immunity tends to be, in contrast to acquired active immunity, slightly different. Here, what you're looking at is the passive immunity is one, first and foremost, temporary. It involves the transfer of say, for example, preformed antibodies, which will go from one individual to the other, and this transfer happens naturally. So, for example, when you have somebody in your family having cold and cough, what you will generally see is the body will go through a particular cycle to, combat this particular, cold and cough that you've had. But over a point in time, what also tends to happen in the family is that you will see this cold and cough gets transferred to another member of your family. And this particular transference in your case, when you've got it, normally takes a time of week to 10 days for you to get better. But when somebody else contracts it, they would get better probably in a bit of shorter time frame of 3 to 4 days or 4 to 5 days. Now, this transfer, which is happening naturally, is happening in such a way wherein either you are in close contact with the other person. Sometimes when we look at referring this to is also the aspect of when mothers or when ladies are essentially pregnant or carrying a baby, then some of the infections can actually get transmitted from the mother's blood through the placenta to the baby as well. And in this case, the transfer is happening naturally, and the baby would actually be producing or having what is called some sort of passive immunity to the infection, at some stage during the duration of their life when they are, growing up as individuals. Now, the other thing that we also look at is when sometimes we look at artificially inducing this passive immunity through the route of vaccination. And that is where we get to see that passive immunity provides immediate but a short-term protection against specific pathogen, and for which your body already has the antibodies. So look at this as an example wherein you get cold and cough every year, certain times of the year. When the weather changes or when the weather pattern changes, you definitely get cold and cough, and everybody gets infected with cold and cough. So your body has the antibodies, the body gets immune, but obviously it still needs a bit of time to be able to, let's say, spring into action and put these antibodies in place so that you're able to get better or able to get back to your original state. But you still will have a bit of infection, and that would mean that you would have this for a certain amount of time, and after which it goes away. But your body remembers that this particular antigen or this pathogen produces this antigen, and it saves that information, in terms of memory, in terms of the information within the T memory cells, so that if it is to happen again, these antibodies can be sprung into action pretty quickly, and they would help you acquire or stop the spread of infection. This is also true, for example, when you look at the COVID-19 virus, for example, a lot of people which are considered having vulnerability are also given doses of flu jab or the COVID-19 virus every year during the start of winters, or when extreme temperatures or climate obviously changes happen. So, for example, moving from autumn to winter, people who are considered vulnerable over the age of 50 or 60, or if they have underlying conditions, they would have received a text message from the surgery to say you are requested to come in and get a flu virus jab or a COVID-19 jab, because this would give them passive immunity, which is short-term immunity, and they would be looking at the vaccination providing say, for example, providing an unharmful version of the pathogen into the body, which would basically activate the T cells, but in specifically the memory T cells, so that there are antibodies produced if the infection is to happen. And this passive immunity provides immediate but short-lived protection against the specific pathogen when we look at human body getting infected again. So if I put it this way, that it is important for us to understand the difference between when we talk about acquired immunity, but within acquired immunity, we talk about active and passive immunity. And active immunity is achieved through the body's production of antibodies in response to pathogens exposure and offers a long-term protection, whereas passive immunity needs to be boosted, or sometimes you say booster doses have to be provided, which involve the transfer of antibodies, and the vaccination uses the process of injecting antibodies that would provide temporary protection against the specific pathogen if the body is to be, if the body is infected or it gets into a state wherein it is infected by that, specific type of pathogen. And that is where vaccination comes in, because it allows immediate response, but at the same time, short-lived protection against the specific pathogen by introducing antibodies in your body, which can be obtained through the route of vaccination, and they allow the body to then start producing relevant cells to be able to fight the process of infection. Is this bit clear? So on my side, what we've also done is created a bit of a table here to differentiate in terms of why these two are important and how do we differentiate between these two types of acquired immunity. So active being long-term, passive being short-term. Active being when your body produces its own antibodies in response to the pathogen. Passive being through vaccination, you are given antibodies essentially, and that is primarily going to help initiate a reaction in the body should a pathogen attack. Then the memory T cells would be producing enough antibodies to be able to fight the infection. In some cases, we learn that, when we were looking at COVID-19 vaccine, there were, instances where the body can show a reaction. That means it might react when an antibody is introduced in your bloodstream. Your body might react, might not accept it. And in certain cases, we saw one in, a few million cases resulted in blood clots or, high fever or maybe some sort of negative reaction, which is where the body wasn't accepting the antibodies injected, for the purposes of, providing you immunity against COVID-19 virus. And then active immunity does take a bit of time to kick in because your body is naturally producing these antibodies and understanding and obviously looking at, meeting the infection and and reacting to the infection. And this was highlighted in the video saying that, although T cells are present in millions and billions in your body, but they are normally in the lymph nodes. So the process through which the infection and the antigens are carried to the lymph nodes for the right type of T cells to be released was the process wherein dendrites are involved. And that dendrites, those cells basically have the antigen attached to it and they travel to the bloodstream. When they pass through the lymph node, they activate this specific type of T cells. And that is where the immunity through the active side takes a bit of time to get activated in the body because it's body's natural defense mechanism or defense system actually kicking into gear, whereas passive immunity tends to provide an immediate response, but although being a short-term response, keeping in mind that is normally initiated through the vaccination route. So these two is what we need to differentiate and understand in the first assessment criteria. That is to understand what is acquired immunity, what are the two different forms of acquired immunity, how they are different, and how does the body or human body, process or defense mechanism kicks in when we are faced with a particular pathogen, whether it's going to be a response which is going to allow active immunity to work, or in this case, if the body's response mechanism is not kicking in and the person is showing severe symptoms of infection, including inflammation, fever, and other symptoms which start to show, then in those cases, obviously, you visit the doctor, you go and see a GP, you see a specialist, and in those cases, after the blood test is done, immediate, provision for either medication, antibiotics, or vaccination is done, and that is to provide an immediate response in the case of passive immunity. Is that okay? Any questions on this? Okay, let's go to the second assessment criteria, which talks about describing the major components of the immune system. When we talk about the two different forms of response that the human body creates, when we talk about, humoral immunity and cell-mediated, immunity. So when we talk about the major components of, the immune system, let's bring in that diagram again. So this particular diagram actually highlights, the major components of the immune system. Now, when we talk about humoral immunity and the cell-mediated immunity, how do we differentiate between the two types, is that these are two types of adaptive, immune responses which your immune system actually shows when it is trying to defend your body against the entry of a pathogen, or a pathogen like bacteria, virus, or any of the toxins which the cells are producing in your body, and your body is showing a reaction through inflammation, high fever, or any sort of non-normal reaction which your body is actually showing. It could be swellings in some cases, it could be decoloration of skin, it could be increased body temperature, which is generally termed as fever. It could be, reactions which, make you, say, for example, sometimes you feel weak, you feel lethargic, or in some cases you lose your appetite. And those are, essential, let's say, signs which your body is actually showing, or giving you signs which it is showing, and then it is allowing you to understand that there is an infection which is taking hold, and that is why your body is actually trying to show these kind of responses, which is where what is happening because of the responses, the different components of the immune system are getting into action, and they would then provide the defense against that particular pathogen. Now, there are obviously some bits of overlap that we get to see sometimes when we talk about the humoral and cell-mediated immunity, but essentially when we talk about this in detail, what we are looking at is that the humoral immunity produces antigen-specific antibodies, and they are primarily driven by the B cells. The cell-mediated immunity, on the other hand, does not produce antibodies, but it puts the whole system into gear, and that would be looking at specific types of T cells and attacking the specific antigen or toxins which the pathogen is actually releasing. So the cell-mediated immunity tends to be a more elaborate response, produces a more elaborate response, from the body, and this particular elaborated response is more targeted. It is going to take a bit of additional time, because if you recall this with regards to the video, it basically said that these T cells and T memory cells and the B cells will go and further provide this information to other cells in the body, and they would kind of recruit these cells to form a part of a bigger defense which the body is trying to put together. So when we do look at cell-mediated immunity, the word that should come to your mind should be cytokinins, and we looked at in that video. So when we look at cell-mediated C, and cytokinins should be coming to your mind, because within the T cells, what we look at is that the cell-mediated immunity essentially relies on the cytokinins, or CTLs, as we were seeing in that video, and they were these cytokinins or lymphocytes, and they, together with the helper T cells, recruit all the other types of cells which can recognize that antigen and would help in providing a bigger defense against that infection which is being caused by the pathogen, or the toxins which the pathogen is essentially releasing into the blood. So they would bring in the macrocytes, they would bring in the plasma cells, they would bring in the cytokinins, they would bring in the killer T cells, they would bring in the neutrophils, and this response that your body produces primarily to form a larger defense against fighting infection in your body would be done through the cell-mediated immunity. So humoral immunity tends to produce antibodies which are specific to a type of antigen, and it is normally the first line of defense which the body would produce. But the cell-mediated immunity would be wherein the infection is spread, or the infection is fast spreading, and it is not something which the macrophages, through the process of phagocytosis, which was explained in the video, that means the cells, macrophages, go and engulf the pathogen and then try and neutralize it by digesting or breaking it down into components. That process cannot happen, and what then is required is that the information needs to be carried to larger part of the body, specifically through lymph nodes and spleen, and that would allow more and more different types of T cells to be activated, because they recognize the antigen, and they would then become they would get grouped together and obviously then fight the pathogen in the body. And this would essentially be related to, looking at cell-mediated immunity. So when we talk about the concept of what are the major components of the immune system, very clear major components of the immune system would be, your thymus, your lymph nodes, your spleen, your bone marrow, and your skin. And obviously, when we look at bowel, the mucous membrane, which is in the nose and throat, and obviously mucous membranes, which are in your bladder, urinary tract, and the genitals, and the tonsils essentially would be, the other main components of your immune system. So some of them tend to show signs of inflammation and fever, or enlargement, as we call it, pretty quickly. And that would be, through your body actually trying to, counteract the pathogen or the bacteria, virus, fungi, whatever we call it, the pathogen essentially through humoral immunity. But when this infection starts to spread, then the body develops, antibodies, but it also would need to produce a lot of antibodies, and it will also recruit a large number of different types of white blood cells or leukocytes, B and T cells, further divided into cytokinins, killer cells, helper T cells, macrocytes, plasma cells, and they would then form the larger defense mechanism by, controlling the spread of infection in the body, and that would be done through the cell-mediated immunity. So these two parts have to be very, very clearly understood in terms of, discussing this particular assessment criteria. So when we look at going further, I've created a few slides which primarily explain what is humoral immunity. And I've also explained how antibodies are actually produced in the human body, and then what type of antibodies actually fight the antigens, which is where the antigens are specific to a particular pathogen. And if the body has had this infection before, then it will be, active immunity. And if it has not had this antigen before, then in this case, it will be passive acquired immunity, and that would be provided through either vaccination, medication, and that would then be, looking at fighting or providing defense against the infections in your body. And then what I've also done is I've explained what is cell-mediated immunity in detail. And when we look at the cell-mediated immunity, what are the different types of white blood cells, specifically the T cells, which are produced in the body, which would then allow the body to essentially, look at providing cell-mediated immunity or immune defense system in the body. And there is where we looked at in the video also the CD4 or CD8 plus cells, which are the killer T cells, are produced in association with cytokinins, which will neutralize the antigens, or in some cases, these cells will bind to the antigen so that the virus gets confused, or the bacteria gets confused, the pathogen gets confused, that which cells it needs to infect, because it's like having the outer tentacles which are blocked by, some sort of, say, cytokinins and these killer T cells, which basically would not allow it to understand that whether this cell has been infected, not infected, and it confuses the pathogen, and thereby it gives more time to the body's immune system to neutralize these through the route of neutrophils and cytokinins, which will be in attacking the pathogens to dissolve them, to neutralize them, or to basically engulf them through macrophages and then excrete them through your body. So this particular concept is something which is important, because it will also be covered in the assignment. And it will talk about what is humoral immunity and cell-mediated immunity, and what are the body's responses or reactions to both kind of immunity when a pathogen tries to enter the body. So this is something that you need to be very, very clear about, because this part of the coverage that we are doing in Learning Outcome 4 actually relates to the human immune defense system. And it is important for you to understand that while we know that there are different kinds of cells in the body, but what we also need to do is go into a bit of detail and understand the different kind of cells and what are these cells, which are white blood cells, and their different types, which are essentially going to be fighting any sort of infection which enters or is caused by a pathogen in the human body. Is that okay?
Yes.
Okay, let's go to the next assessment criteria, which talks about, difference between primary and secondary immune response, or which is basically the response which, the body actually produces when you start, say, having an infection. Now, when we talk about, primary and secondary immune responses, there are two distinct phases, of the immune system's reaction to any sort of antigen or a pathogen which is entering your body. So a primary response and a secondary response, but they are basically going to happen at some stage in your body with response to an antigen or a toxin being released by the antigen in the human body. But they are basically going to happen in tandem. That means they will happen together. They are just two different phases of when will the primary response happen and when will be the secondary response happen. So when we look at differentiating between primary and secondary immune responses, what we are looking at is that the primary immune system response occurs when the immune system encounters an antigen for the first time. So COVID-19 virus, for example, was not something which was known to be present or known to be, infecting the humans, which is the, virus, SARS-2 virus. We weren't aware. But when it happened for the first time, what it meant was that the human body or the immune system encountered the antigen or this particular pathogen for the first time. So the initial response, which triggers or initial exposure to the pathogen, which triggers a response to combat, this virus, takes a bit of time. And it needs a bit of time because we need to understand what the pathogen is and what kind of reaction it causes or infection it causes within the human immune system. The secondary immune system response to this, on the other hand, is when we clearly see that the exposure to the antigen has happened. And this time the exposure to the antigen, because there is exposure already, the human body has the exposure to it. So in this case, there is a rapid and a robust reaction which the body, produces when it comes in contact with it again. So people, when they were first contracting COVID, there were severe responses of, breathlessness, pneumonia, which then set in. And obviously at some stage, people then needed oxygenators because it creates difficulty in breathing. It leads to water collecting in your lungs. And that is where the organ, if the body organs do not get oxygen and fresh oxygen, then your body organs start failing, pneumonia sets in, and that is where the loss of life started to happen. But in the instant when your body became let's say aware of that this is something that your body can be infected with, second time round when people had COVID or COVID virus infecting them with a different variant, the response from the human body in terms of its defense mechanism was much more rapid, quicker, and much more robust. And some of these symptoms which the human body actually saw were lesser or less severe as compared to the first time round. So when we talk about primary versus secondary response, we need to look at how the your B cells are stimulated by the antigen and how quickly they become activated and then help to differentiate by creating antibodies in relation to combating the infection. So when we talk about primary and secondary immune responses, these immune responses can be classified into two different types. One, exposure and versus subsequent exposure. So depending on exposure for the first time, your body might take a bit of time to adjust to the infection and in this case, the pathogen. But the second time round, the secondary immune system might kick in quite quickly because the memory T cells have the antibodies already present, and it starts to replicate and provide a quicker response. The second thing which we would be looking at differentiating between primary and secondary would be on the basis of speed. For example, when we talk about primary response, it is characterized by, say, for example, it is slow and it is normally weaker because the body is naturally producing antibodies to be able to combat that pathogen because it's coming in contact with it for the first time. So your immune system is learning. It'll take a bit of time, but once it learns about the pathogen and the reaction it is causing, the antigen which is releasing certain type of toxin, it will mount a greater defense against that simply by recruiting a lot of other B, T, and different type of T cells to fight that. When we look at secondary immune system, in this case, when we look at it in relation to speed, what you're going to see is the secondary response is going to be much quicker because your body is exposed to it, and it is going to be much more potent. That means it is going to be much more severe. So the memory B and T cells, remember that this is something that your body has already been exposed to during the primary response, and it will allow an accelerated reaction to happen against the same antigen or pathogen when your body comes and encounters it again. So when we look at the speed at which the reaction happens, we can again use and differentiate speed to differentiate between primary and secondary immune response. The third bit that we would be looking at would be antibody production. Now, in the primary response, the production of antibodies is specific to an antigen which is, entered your body or starting to cause some sort of infection. These antibodies will hopefully neutralize the antigen, but it will take time for it to peak up. So when you look at fevers, when you look at, say, for example, certain type of fevers like dengue fever, malaria fever, or any sort of fever that you normally have, they take time to peak. So normally in the first few days, your body will basically be producing a lot of antibodies. Your body will show higher temperatures, and in this case, what will happen is once the body has produced enough antibodies and it started to overcome the infection, you would generally see your fever tends to taper off and your body temperature starts to become normal. You start regaining strength, and obviously that is when you basically get the feeling that your body is now fighting the virus or the bacteria, and that is where the body is actually winning. So because of the increased amount of antibody production, which starts to happen at a slower pace, but it ramps up at some time, that also shows that during primary immune system response, you would see a slow but a sustained a process through which your body will produce antibodies and then try and overcome the pathogen or the reactions to the toxin which the pathogen is releasing. Now, in response to secondary immune system, because there are memory T cells which are already present, and if the infection or that kind of a fever is to happen again, your body will quickly recognize that antigen, and that will create, the straight away go into the process of creating an antibodies, which will be quite rapid and substantiated. And this would mean that this would help you to overcome that fever or that particular infection much more quickly. And that is also going to be a mechanism through which we can differentiate between primary and secondary immune system response. So production of antibodies tends to be much quicker and much more, substantial in the case of secondary immune response because the body has been exposed to the antigen before. Now, if I look at introducing one more parameter, which is primarily looking at long-term aspects of immunity, primary response, immune response would primarily establish the immune system's recognition of the antigen. That means it recognizes that this is the first time it has encountered it, and it prepares to encounter it in the future as well. So what it will do is, once it has successfully, produced the antibodies, it will transfer that information to the memory T cells, and they will store that information. Should your body come in contact with that pathogen again and it tries to cause infection, then the secondary response would be much quicker and would be initiated instantly. If I look at it from a long-term perspective in terms of immunity, secondary response is going to be associated with the development of these memory T cells, and these memory T cells would basically be providing the human body with long-lasting immunity. So here, what will happen is that you are going to be having these cells present in the blood or in your lymph nodes, and they would provide more resistance to any such future infections which are coming from similar pathogens. So when we talk about differences between primary and secondary immune system, we are going to look at differentiating this across 4 different parameters. One could be exposure, first exposure versus subsequent exposure. It could be speed. It could be antibody production, speed at which the antibodies are produced and how many are produced. And the fourth one, or the last one, is going to be long-term immunity. And when we look at that, that is where you are going to differentiate that what happens when your body is faced with infection. The defense system produces a response. The response tends to be primary and secondary. Primary in the case when the antigen or the pathogen is infecting your body for the first time, but secondary because the body has had this infection before, so it will straight away swing into action to produce antibodies using the memory T cells and produce a far larger response to combat the infection by deploying a lot of different types of T cells to counter that particular pathogen or the toxin which the pathogen is releasing. Now, this is what is explained in the graph here. So what you generally get to see is the graph which basically talks about primary response to the in terms of your body producing primary response with regards to defense, and then the secondary response which the body is trying to produce again with regards to the defense your body is actually producing when it is fighting the infection, and that is where you see the length, the I would say the ferocity of the production of antibodies, and the days in which you recover, and how, say for example, you get back to normal. So in the first exposure, you would see the cycle tends to be more even. So it will peak at some stage, and once the peaking has happened, when that means your body has produced enough antibodies to be able to overcome the infection, it will slowly and gradually go back to normal. Now, in the case of secondary response, what you're going to see generally is that when the body already has the antibodies present, so what it will do is primarily then look at producing larger response, and that larger response essentially would then be dealing with the infection at a much quicker pace in the body, because the body is already aware of the pathogen, and that allows the pathogen to the body to basically overcome the pathogen and the reaction it is causing in terms of infection much more quickly in the secondary immune responses. Now, this is also explained in this particular diagram. Yeah, go on.
Is there any this thing that it will happen that a body cell will not produce an antibody? Can that happen?
That can also happen with people which have underlying conditions, or if they're if they are, when I say underlying conditions, that means they have conditions which would not allow the body to react or produce antibodies. So some part of that could be genetic, some part of that could be hereditary, and in some cases, if the body's defense mechanism, is weak, then in those cases you would straight away be looking at, acquired passive immunity, because that is where vaccination and medication comes in for people who do not have enough antibodies or enough white blood cells in the body, and that is why blood tests are done. So blood tests are done to determine what is the density of white blood cells in your blood, And if they feel that it is below a certain level, then in those cases, those people are treated as vulnerable if they were to have a infection. And in those cases, it will be the preferred route of providing acquired passive immunity, which will provide them immediate and short-term relief, but also be a lifesaver because their body is not producing enough, say, for example, enough T cells or B cells to be able to fight infection on its own.
Thank you.
Okay, no worries. Now, in terms of, one or two things which I also want to, kind of show and point out is that these are two different, one is a graph which primarily is showing, the response to how the body's immune system actually responds to, virus or some sort of a pathogen attack. And the other one is actually going into details by showing the types of cells, the Ig cells, the IgM cells, which are basically, cells which activate the antibodies, or either they would basically attach themselves to the pathogen cells so that they are not able to replicate or reproduce or infect other cells. And this is where it shows just the primary response and the secondary response in the human body. So when we looked at that particular video and we talked about the molecular structure of how these cells replicate and then help us fight against the infection, is actually shown in these two images or diagrams in detail. Now, what it shows here is that when we look at the primary immune system, then the B cells are stimulated by the antigen and they become activated, and they then differentiate the antibody secreting cells from the antibody specific cells which are required to fight the antigen. And in the case of secondary immune response, they would normally be the same antigen which stimulates the B cells because the body is already aware of the infection, and this will lead to a greater production of the white blood cells or the killer T cells. That is why this line is showing a bigger let's say area, because the amount of antibodies being produced to something which the body has already been exposed to is going to be larger to basically reduce the reaction in terms of the body overcoming infection. So this is the thing that you need to understand by looking at this particular chart, that the difference is between the primary response and the secondary response. The primary response tends to produce antibodies. It lets the body, it takes a bit of time for the body to peak in terms of the infection to peak, and that is where the body, your human body, is producing antibodies specifically to overcome infection, and that is why there's a longer time it takes for it to produce these bodies, because it has been exposed for the first time. But in the secondary response, as you can see, if we look at number of days, it is starting after the 7th day, or roughly say at the 8th day. But in the case of secondary response, what you're seeing is on the graph here, you can see the body's reaction probably starts on the 1st or the 2nd day itself, and that leads to a flaring of or a mass production of the antibodies required to overcome the infection. The second thing that you see, that when we talk about the peaking is happening around, say, between 14 to 21 days. But here, if you see, the peaking essentially has happened on the 14 days. So again, the secondary immune response is faster because the body has already had exposure to it. And that is where it peaks off and, creates that response to overcome the infection much more quickly. And that is the bit that you need to be able to interpret and understand from the graph here. And this graph is then shown in the form of how different cells are being produced to fight the infection. And that is something, again, you would need to know, because if you know the different types of cells, then you are able to interpret this graph, because it shows the amount of antibody being produced and the days it requires for these antibodies to overcome the antigen which is produced by the pathogen. So in the primary response, as you can see, it peaks at around 7 days. But in the secondary immune response, you see straight away picking up on the 3rd day, when different types of cells, the plasma cells, the T cells, the cytokinins, the macrophages, and the killer T cells essentially start overcoming the infection or the antigen which is being released by the pathogen, and then starts to bring down, starts to become much more effective in terms of fighting the infection in the body. Now, I've also looked at creating a table, and the table essentially looks at the parameters that I discussed with you when I talked about how do we differentiate between, the primary and the secondary response. So what I've done is in this table, I've differentiated that by looking at the definition of the two responses, how you would normally see this response starting, where it would occur, how would the antibodies peak, then would the antibodies be produced again if the infection is to happen again in the human body, how quickly that would happen, and then looking at some of the other factors in terms of what are the various kind of cells these primary and the secondary immune response would be calling into action to produce a defense against the infection which the pathogen is trying to cause in the human body. So this table would help you essentially, go into details of understanding the key differences between primary and secondary immune response, which the human body produces in response to the infection or the pathogen which is trying to enter and cause infection. Is that okay? Any questions on this so far? Okay, that's great. So this brings us to the end of, today's session. And for those of you who want to read a bit more in terms of the video that I put forward in the starting, along with that, if you want to understand the key concepts of different types of immunity and go into details of the immune system, then my session would be to look at these 3 links, which I put forward in the plenary slide on slide 25. Towards the end of the presentation, which will provide you a bit more detail for you to study and understand how we look at, going into details of the human body's immune system and the specific defense it produces when it faces when it is countering antigens or infections primarily within the body. So this brings us to the end of today's session. What we are going to be looking at doing next week would be covering Learning Outcome 5. And on Sunday, we'll be looking at discussing the assignment brief for this particular unit. So until then, thanks for joining in. And if you think of any questions or if you need any additional information, then feel free to get back to me via email, and I'll come back to you and obviously provide more information related to what we've discussed, today.
Okay.
Okay, thank you.
Okay, thank you.
Thank you.
Bye.
Bye.
Thank you.
Bye.
Thank you. Thank you. Bye.